Einstein built his theory of relativity on two fundamental assumptions or postulates about the way nature behaves. The first is based on the assumption that the laws of physics are the same in every inertial reference frame. Consider lifting a ball from a table and letting it drop from rest and hit the floor. We know how the laws of kinematics apply to the freely falling object, and we could calculate the final speed when it hit the floor or the time it took to hit the floor if we were given the height. But how could we tell by watching this ball drop whether we were moving at some constant velocity relative to Earth? Suppose we were in an airplane undergoing straight and level flight at a constant velocity, perhaps at 500 miles per hour relative to the ground. Would we see a change in the way the ball drops? The answer is no, and we would find that all the laws of physics would behave exactly the same, regardless of the relative motion. We therefore conclude that the laws of physics are the same in every inertial frame of reference. For the next postulate, consider a rocket ship moving at a constant speed of 0.15 c toward a stationary observer on the ground. If a person on the spacecraft fires a laser at the ground-based observer, what is the relative speed between the laser light and the ground-based observer? Before we answer that question, we know that another observer who is at rest with respect to the moving ship measures the speed of the laser to be c. This can be argued on the basis of the first postulate that the laws of physics are the same in every inertial frame of reference. If there were no windows on the ship, how would anyone inside even know that it was moving relative to the ground? After all, isn't the Earth hurtling through space at some breakneck speed? Relative to something, anyway. The more important question, however, is what speed does the earthbound observer measure for the laser light? One might reason that if the ship is going at a speed of 0.15 c, and the laser light moves at speed c relative to the ship, that the ground-based observer should measure a speed of c plus 0.15 c equal to 1.15 c. That is, a speed greater than c, the speed of light. And this would be the classical result of the addition of velocities far below the speed of light. However, this is not the case for light. Surprisingly, the answer is that the ground-based observer measures the speed of the light to be c, no greater, no less, no matter what the relative speed between the observer and the source. This result has startling implications regarding time and length at relativistic speeds. The postulates of relativity are the following. The relativity postulate states that the laws of physics are the same in every inertial reference frame. The speed of light postulate states that the speed of light in a vacuum, measured in any inertial frame of reference, always has the same value of c, no matter how fast the source of the light and the observer are moving relative to each other. These postulates will now be used to examine the relativity of time and length.